Now let's talk about a translated parabola. This time you'll notice that we've been given the squared term already isolated. Y minus 3 squared equals 8 times x plus 1. So the first thing we want to do is recognize that the y squared is the squared term. So this tells us that our parabola is going to go left or right instead of up and down like our parent shape we're used to seeing. The other thing we realize here is that this is in that new form. So let's take a look at this form. This is in the form of y minus k squared equals 4 times p times x minus h. Now, notice that x minus h. We've seen that before. That tells us that the h value here is actually the opposite of what we're looking at. So we can see right now that our vertex is going to be at -1, comma, and the k value is also in that y minus k form. So it being the opposite of what we see, y minus a positive 3. So we see that our vertex is now at -1, comma 3, right about there. There's our vertex. Now the other thing we can figure out is the focus and the directrix. Remember, 4p, p is that value that's going to tell us that. So we're going to take 4p, and that's going to equal the 8. So we divide both sides by 4, and we find that p equals 2. So it's a positive 2, and our graph is going to open left or right. The positive 2 direction would be to the right. So there's our focus, 2 units to the left. There's our directrix. I know it wasn't the straightest of lines, was it? Now, our parabola then, again, remember, that latus rectum idea. This number here is the latus rectum. It goes through the focus, and it's parallel to the directrix. So 8 units would be 4 on this side, 4 on that side. So our parabola is going to go through those 2 points as well. So if we wanted to draw our parabola right now from our vertex, we could go through these points of the latus rectum. The drawing's not that well, but you get the idea. So this has been translated h and k units. Notice the h still sticks with the x value, and the k still sticks with the y value. In addition to that, we could find the distance p to the focus. There's our 2 units. And the opposite direction to the directrix. So that would be p is -2 to the directrix in that case. The latus rectum is that multiplier, and it's parallel to the directrix. And it shows us 2 more endpoints. There's a whole other way for us to look at a parabola. Now, if we were to go ahead and change this back to the way we're used to seeing it, this over here would be 1/8 in front. We'd still have the same vertex, -1, comma 3, but we would think of it as horizontally compressed by 1/8. So that's the translation of a parabola. Now let's take a look at this idea of a degenerate conic. The degenerate conic means that our conic section here, the ideas from a cone, can actually possibly degenerate to 2 non-really cone-like shapes. 3 of them, actually, I should say. We can degenerate down to a single point if A, C, D, and E are all zeros. We can degenerate to a line if A, C, and either D or E are 0. So we'd have like y equals a number or x equals a number, which would be vertical or horizontal lines. Or we could even end up with a line with x and y in it, a linear equation if just A or C are 0. But right now, what we really want to look into is how do we determine the other shapes based on our standard form without having to graph it or without having to complete the square. The key are these 2 letters, A and C. Earlier in the time when I was talking about circles, I told you that if A equaled C, you're going to have a circle. Okay? So that's pretty helpful. As long as A equals C, you've got a circle. But if A does not equal C, well, then you have either an ellipse or a parabola. And it really is going to come down to this fact. If A times C is greater than 0, meaning it's positive, they're both the same sign. If they're both the same sign, that's an ellipse. If, on the other hand, A times C is less than 0, that means it's a negative number, which means one of these was negative and one of them was positive. They're opposite signs. That's how you get that negative in the hyperbola equation. And then finally, the one that we're kind of most concerned with today is if A times C equals 0. That would mean that one of these variables is 0, at least as long as that equals 0, but one of them is a number. Then you've got a parabola. So we can look at our equation here and determine what shape it is just based on the A and the C values there. So let's say we've got 3x squared minus 3y squared plus 2x minus 4y plus 1003 equals 0. Well, all we're going to do is we're going to hone in on A and C. We're going to multiply 3 times negative 3. We're going to find that's negative 9. They're not the same. One's positive, one's negative. Multiplying does not give us a positive number greater than 0. It gives us a negative. We have hyperbola in this case. If I had simply erased this part here, now A is a 0, C is negative 3, and multiplying it would give us a 0, and that would be our parabola. Notice we've only got one squared term when it's a parabola. So there's your information on the parabola being translated and from the standard form. I hope this helps out, folks. Feel free to come by the video conference and ask some questions. I'll see you then. Hope you're all feeling safe.